Okay, so here is question 4 on the mechanics paper. Um, and even before I sort of read the question, I've sort of drawn the diagram and added forces and angles. So we've got reaction force here, which is always perpendicular to the surface that it's resting on. So this rod is resting on the ground, so there's a reaction force there. This rod wants to slide that way, and that's why friction force is acting that way. That's actually the answer to part A. Friction always opposes the direction something is either moving or wants to move. We've got the mass of the rod because it's uniform, so that's halfway up. It's got a length of 2a, so that's a units up, and then we've got this mass c, which is a little bit further up, and then we've got the string that is holding the rod, and that's perpendicular to the rod, which is quite helpful. I've then added in angles, so this is the angle we're told, theta. So that means that that angle will be 90 minus theta, which means that's theta and that's theta, and also that's theta and that's theta, so that's quite helpful. And then whenever you get one of these questions where it's the same as ladder questions, it's always a three-step process really. Moments about either end. It's easier to do moments about this end. That's A, isn't it? Because you then don't have to worry about these two forces. And the moment is force times distance. Well, these two forces have a distance of 0, so I can ignore them. And then resolving in two directions. So in this case, I'm resolving straight up and horizontally. So let's do that, and then let's have a look at the question and see what it's asking. So moments, there are two forces pulling the rod clockwise. You've got this one, so the moments I'm going to do perpendicular to the rod. So this force has an effect of mg cos theta, and it's at a distance of a units. And then the moment of this force, 2mg cos theta, and that's at a distance of 1.5a. So when we consider moments, we're talking about the twisting effect on this rod. So we want everything to be perpendicular to the rod. And then similarly, we've got an anti-clockwise moment. It's this force here, and that's already perpendicular. So the angle there is irrelevant in this case. That's already perpendicular to the rod. The rod is 2a. I just realised that should say 2a. And there we go. There. So I then do a little bit of algebra. I divide everything by a, which is nice and easy. So this gives me 2t, and on this side I've got mg cos theta, and I have got 3 mg cos theta, so that altogether gives me 4 mg cos theta. So t is 2 mg cos theta. And hey presto, that's part B. That's part B. So we've shown that by taking moments about A. Resolving the forces, so I'm now thinking vertically. So I've got this force going up, I've got these two forces coming down, and I've also got the vertical component of that force, which is acting up. So I've got the two forces acting up, and I've got the combined two forces acting down. And there's no distance involved there, that's just forces up must equal forces down. And then thinking horizontally, well, these three forces are going vertically, so they'll have no effect horizontally, but this one is pulling one way, and then you've got the horizontal component of that force. Now, you know me, I like to use cos, so I would normally say t cos of that angle, but I don't know that angle, so that's why I've had to do t sine of that angle. Okay, so so let's have a look at the question. We've already sort of stumbled across an answer to B. We've now got to work out that R is 57 mg over 25. Well, so this is the formula that involves R, and so I'm going to take that formula and work down here. So if I rearrange that formula, so it says R equals, you get 3g minus t cos theta. But we've just worked out, haven't we? We did that up here, that t is 2mg cos theta. So I'm going to rewrite that, replacing it with 2mg cos theta. And we're told that cos theta is 3/5. So then it's just sort of all multiplies out quite nicely to give that as required. We're then told to show that the coefficient of friction is 8 over 19. Well, the coefficient of friction comes from this formula F equals mu R. And we've got a formula with F here, so I'm going to use that formula here. It's in equilibrium still, and we're told that the rod is in limiting equilibrium, which means friction has reached its maximum value. So F is mu R, and T, remember, up here, is 2mg cos theta. So I've got 2mg cos theta times sine theta equals mu R, and don't forget we've just worked out what R is down here. Now this is a problem. We're told what cos theta is, we don't know what sine theta is, but if cos theta is 3/5, then this could be a triangle with that angle in it, couldn't it? Because cos is adjacent over hypotenuse. We know theta is acute, so we're okay drawing a right angle triangle like this. And then we just use Pythagoras, that's 4, so sine theta must be 4/5. So this isn't a particularly pretty sum, but it does fall out as mu being 8 over 19 as required.